students, in my last video I told you what is linear differential equation with constant coefficients. Today we will learn about the solution of that equation. As I said, the linear differential equation of higher order with constant coefficient, the general form is an dny upon dxn plus an minus 1 dn minus 1y upon dxn minus 1 dash 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 a0 y is equal to fx. And I told you that if fx is equal to 0, if this fx is 0, it is called homogeneous, otherwise it is non-homogeneous. When it is homogeneous means when fx is equal to 0, the solution of the differential equation is only complementary function. Okay. And in the case when it is non-homogeneous, when f of x is not equal to 0, in that case the solution y is complementary function plus particular integral. So in this particular video, I'll teach you how to find out the complementary factor or complementary function. What is the first step? I'll take a basic equation to explain you. Suppose you have d2y upon dx square minus 2 dy by dx plus y is equal to 0. Correct? Now, the very first step what you have to do, replace d by dx by capital D, which is an operator. Okay. So, this equation will become, since it is d2 upon dx square, this will become d square. Okay. And y is there. Minus, this will become only d, 2d plus 1. And this y I am taking common from all the three terms. This is equal to 0. So sometime in exam they give this format, sometime in exam they give this format. Okay. Now step 2 is to write auxiliary equation. Now how to write auxiliary equation? Replace this d by m and equate it to 0. So basically this format can be written as f of d y is equal to 0. So for auxiliary equation you have to write f of m is equal to 0. Right? Once you get the auxiliary equation, step 3 is find roots of the equation. Now based on nature of the roots, we will write down the complementary factor. So what are the different cases? See now, cases and the complementary function, and let me write here some example together I'll explain. Now case 1. Suppose you have got the distinct root like m1, m2, m3. So what will be your complementary factor? Your complementary factor will be c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3x. This will be your complementary factor. Let me take an example. Suppose 1, 3, 8 are the roots. So you will write down c1 e to the power 1x plus c2 e to the power 3x plus c3 e to the power 8x. Okay, and we have to always take care, if degree is 2, I will have 2 roots. If degree is 3, I will have 3 roots. Now suppose my roots are 0, minus 4 and 5. So what will be the answer? c1 e to the power 0x plus c2 e to the power minus 4x plus c3 e to the power 5x. Suppose my roots are 1.7 and say root 3. In that case, my answer will be c1 e to the power 1.7x plus c2 e to the power root 3x. So don't worry about the decimals or roots. Whatever is coming, you put it here. Right? So this is your case 1. Now what is your case 2? Case 2 is when you have repeated root. Repeated roots means suppose you have m, m, m. So what will be the CF? C1 plus C2x plus C3x. Since it came 3 times, so C1, C2, C3 came. Close the bracket. E to the power mx right? Now let me give some examples. Suppose you have the roots 2 comma 2. So my answer will be c1 plus c2x, because 2 times repeated, so c1 plus c2, e to the power 2x. If my roots are minus 3, minus 3, minus 3, my answer will be c1 plus c2x plus c3x square e to the power minus 3x. Correct? Now suppose my roots are say minus 2, 3, 7, 7. So how I will write down the answer? See, minus 2 is coming only one time. So I will write c1 e to the power minus 2x plus c2 e to the power 3x. Now 7 is repeated. So c3 plus c4x e to the power 7x. Understood? Now suppose my roots are 0, 0 and 5, 5 and 6. Okay, how I will write down the root complementary function? First 0 is repeated. So c1 plus c2x. And then e to the power 0x, we know that e to the power 0x is 1. So gone. Then plus c3 plus c4x, because 5 is also repeated. So e to the power 5x plus 6 is coming single time. So c5 e to the power 6x. So this is how you can write down the CF. Now come to case 3. Now case 3 is your complex roots. Suppose your roots are alpha plus minus I beta. So how you will write down the CF? CF will be e to the power alpha x, means the real part, in bracket c1 cos of beta x plus c2 sin of beta x. If suppose the complex root is repeated and alpha plus minus I beta, so my answer will be e to the power alpha x in bracket c1 plus c2x, because it is repeated, cos beta x plus c3 plus c4x and sin beta x. Correct? Now let us see some examples. Suppose my roots are say 2 plus minus 3i. So what will be the complementary function? My answer will be e to the power 2x in bracket c1 cos 3x plus c2 sin 3x. Correct? Now suppose I have say 1 plus minus 7i comma 1 plus minus 7i. So what will be the answer? E to the power x c1 plus c2x cos 7x plus c3 plus c4x sin 7x. Correct? Now see one more example. Suppose you have the roots say 2, 3 plus minus 5i. So how you will write? First it is a real root, so c1 e to the power 2x. 3 is a real root plus c2 e to the power 3x. Then this is a complex root, but alpha is 0. So e to the power 0x is 1. So no need to write that. Then c3 cos 5x plus c4 sin 5x. So this will be my complementary factor. So this is how we have to find out the complementary factor. So what will be the steps? Let us quickly revise. The very first step is you write it in the form of operator capital D. Okay. Now once you got it in an operator capital D format, you write down the auxiliary equation where you replace capital D by M. Once you got the auxiliary equation, find out the roots of the equation. So for finding out the roots of the equation, if it is a quadratic equation, you can do it by splitting the middle term or by any other method which you have learned in the previous classes, or you can use the calculator. For cubic equation also I will suggest use the calculator. Fourth order degree equation also use the calculator. Fifth order degree equation, you should do the synthetic division and reduce it to 1 degree first, and then you should use the calculator. Now here you should take care of one thing. While using calculator, the complex root will come separately sometime, like alpha plus I beta and alpha minus I beta. But always remember that complex roots comes in a pair. If 2 plus 3i is a root, 2 minus 3i is compulsory a root. So it is always plus minus. Okay, so they are counted as two roots, but they always come in a pair. It can never happen that 2 plus I beta is a root and 2 minus I beta is not a root. So that will always come in pair. So that you take care in calculator, it will show twice. You should not get confused. Or if it is showing only plus, understand that minus is also a root. Also, one more thing you have to take care in the calculator. Suppose you have the roots 2, 3 and 3. So when you will solve in calculator, it will show 2 and 3. So you need to understand the second one is repeated root. If the degree is 3 and calculator is showing 2, 3, then the third root is 3 by default. That you need to understand. Also, there will be some equation in which m will be common, like this. So first take out m common. So it will give you m is equal to 0, 1 root. And the remaining you put in the calculator to get the remaining roots. So that small things you have to take care, because once you have got the roots, then finding out CF is not very difficult. So I hope you understood the concept of complementary function and how to find out the complementary function. In my next video, I will teach you how to find out complementary function using the questions directly. These are the cases and formulas I told you. Next video, we will do the questions. Thank you.